This is problem number 4 from section 1.5. In this problem it says find the domain and range for the function f of x equals 1 over 4 plus e to the 3x. Now how do I find the domain and range of a rational? And inside the rational in the denominator we have an exponential. Well, let's first of all look at the exponential. So I'm going to say we're finding domain here, then we'll range here. Well, let's start by looking at what is the domain and range of just e to the 3x. So e to the 3x, what is its domain? Well, I can plug in, because it's an exponential, I can plug in any positive or negative number I want for x. Right? Because I can have negative exponents, I can have positive exponents. So this is going to be negative infinity to infinity. Now what happens as I plug in, though, negative infinity into this function? Well, remember, we just looked at the graphs of the exponentials a couple problems earlier. And when we look at the graph of the exponential, exponentials always, for the most part, unless they have some sort of shift, they're always going to approach 0 for the parent function. So as you get farther and farther to the left with the exponential function, you're approaching 0. So 0 is essentially the smallest number that this exponential gets close to. I guess is how you would put it. It never touches it, but it gets close to it. If I plug in like a negative 1,000, I get a really, really small fraction, which is close to 0. But if I plug in like something close to infinity, well, I get a really large number. So my range for that function, for just e to the 3x, is going to be 0, I can't touch it, all the way to infinity. Now, how am I going to use this with this rational problem? Well, I know if I were to just say that y equals, and then say y equals e to the 3x, and then write this as, this piece as f of x equals 1 over 4 plus y, right? Replace the e to the 3x with y. I know that to solve this, I would say 4 plus y, to find the domain, I should say, 4 plus y cannot equal 0. I'd subtract the 4, and y cannot equal negative 4. So I know, just looking at this rational function, if this e to the 3x gives me a negative 4, then I have a missing piece in my domain. Well, if I look at the range of e to the 3x, the range of e to the 3x is 0 to infinity. So does e to the 3x ever give you negative 4? No. You never get negative 4 for an output for e to the 3x. So because of that, it's impossible for us to get a missing domain value for our denominator, because we can never reach negative 4. Another way to think about this is if you just took this function in the bottom, this 4 plus e to the 3x, this expression, and we said that it had to be, remember we always say, cannot equal 0, and we start to solve this, so we get, subtract the negative 4 over, we have e to the 3x cannot equal negative 4, and then we do the natural log of each side. That'd be natural log e to the 3x cannot equal natural log of negative 4. At this point here, I can kind of stop, because natural log of negative 4 is a domain error. It doesn't give you a real solution. So if I go about just doing what I normally would with a rational function and say, hey, this bottom cannot equal 0 like I did here, I'm going to run into a domain error, meaning I cannot actually get 0 in the bottom. So what's the domain of this function? Well, I can plug anything in, because my e to the 3x value always gives me 0 to infinity, so I never get negative 4. So this domain is negative infinity to infinity, just like the e to the 3x function. Now what's the range then? What's the range of this function? Well, I know the smallest value that I can get for e to the 3x here is 0, right? That's the range for it. So if I plug 0 in there, I get 1 over 4 plus 0, which is 1/4. So 1/4, all right, is one value that we can get when we use the smallest range value of e to the 3x. If I plug in something close to infinity, I get a really large number here. So I end up with 1 over a really large number, which is really close to 0. So this range for the function is going to float between 0 and 1/4. So I'm going to have 0, but I can't touch it, to 1/4. But again, I can't touch 1/4 either because this function it's not actually ever 0. So I also have 1/4 being something we can't get, but we can get close to. And this is the domain and range for this rational function with the exponential in the denominator.